So thank you for joining us here today. There will be a Slido app for questions, so we will take those throughout and then answer questions that come in through the app. The QR code is on the screens. So to begin, this is the panel on the new exploration, a new era of lunar exploration that has begun. In the early morning hours of November 16, 2022, the massive Space Launch System core stage and solid-fueled boosters erupted into life to launch the first of human-rated spacecraft to the moon in over 50 years. After a series of perfectly timed burns, the uncrewed Orion separated from its SLS and 2 hours later put itself on a path to lunar orbit. This marked the beginning of the Artemis program and ushered in a new era of space exploration, and this is just the beginning. Artemis I was the first in a series of increasingly complex missions that will enable human exploration to the moon and Mars. The primary goals for Artemis I were to demonstrate the Orion, the Space Launch System rocket, exploration ground systems, and all of the support systems across the ground, air, and spaceflight environments. These goals culminated to ensure a safe re-entry, descent and landing, and recovery of the Orion spacecraft to prepare for Artemis II and our first crewed flight. This panel will talk about what we learned from Artemis I and some of the lessons that will inform our future missions. This plenary will also discuss the balance of the Artemis program and how future exploration objectives will be achieved. We will talk about how the global lunar utilization, where government, private sector, and academia can maintain robotic and human presence on the lunar surface. And the panel will also touch on Artemis science, one of the foundational elements of our exploration. So what we can do on site between robotics, human explorers, on and around the moon and Mars, and aided by all of the systems that all of the international partners bring. So join me in welcoming our panelists. First, Mr. Jim Free.
Thanks, Najud. Thank you very much. Good afternoon. It is very exciting to be here. I have fond memories of November 16th and December 11th. Great memories. So could I have the next slide, please? Our first mission, as Najud talked about, let me go back to the title of this panel, is that exploration has begun. This isn't about a paper program any longer. It's not about PowerPoint briefing slides and things we want to do. There's things we have done, and we're on a near-term path to do, which is the greatest thing. That began with Artemis I, tremendously successful mission, some of which Najud highlighted. These three pictures tell it all to me. Launch of a first-time rocket, incredibly accurate precision, perfect operation of a spacecraft in orbit, and then a great return and recovery, which is the tremendous first step that we needed on this international exploration effort. Go to the next one, please. So high level, we'll get into some details hopefully in the questions, but these are our series of missions that build on each other. I love the way this chart is structured. Our first uncrewed mission to really test our systems top to bottom, our crew transportation systems. Also an international mission. We had international contributions in the European service module, a number of CubeSats that were international as well. Moving with confidence to our second mission, where we'll fly humans for the first time back to the moon and the vicinity around the moon. Tremendous crews already been named. Moving from there with that confidence that our life support systems work well to our first landing, and then getting into a steady cadence of missions where we'll do our landings from our gateway, our lunar orbiting station. So an incredibly exciting time for us in the missions that we have, incredibly exciting for the science we're gonna get, and also in the international cooperation that is really the foundation of what we're doing for lunar exploration in Artemis. Thank you.
Hi, everyone. It's a real pleasure to be here. My first time in Baku. It's been an amazing experience so far. So I want to tell you, next slide, please, Najud, about the science on Artemis 1 and then the subsequent Artemis missions. So as you will see over here, for NASA's Moon to Mars objectives, science plays a center key role in everything Artemis, and you'll see that on the next slide. That even though, as Jim just mentioned, Artemis 1 was really the mission that was going to ensure that SLS did its job, that Orion came back safely. But in spite of that, science is so front and center that we actually had 15 science payloads on Artemis 1. There were 5, as you can see on the left side, which were inside the Orion capsule that went around the moon and came back. And then there were 10 others that were these CubeSats that launched as secondary payloads. And what was good about this mission is that it tested that capability of sending secondaries to do additional science to orbits that they otherwise may not have been able to get to very easily. And with the, I don't know if the yellow asterisks are clear enough or not on the slides, but there were at least 5 of these experiments that were international collaborations. So again, partnerships and several of them that had industry or commercial partners. So again, partnership is a big part of the science that we've been doing. At the bottom middle, you can see Bioexperiment 1. And that was an experiment that our division, Biological and Physical Sciences Division in NASA, had 4 experiments in that payload. And the Artemis group actually did an amazing job of returning our science to us 7 days after return, which was earlier than we expected, which is fabulous for the science because for some of these samples, having them returned to the investigators' lab ASAP is extremely important for the science integrity. So we're very excited, and the investigators are working on that mission, on the experiments. This slide is just to show you that, we already talked about science on Artemis 1, and the plan is that as we go on to the subsequent Artemis missions, we expect that there will only be a growth in the opportunities to do science. And a couple of things that I wanted to point out here for the investigator community, particularly the international investigator community, as well as the industry and commercial side of it, there are various opportunities. There's the Artemis 3 geology team that was selected that will be doing work. They will be preparing for the mission as well as monitoring in real time as the sample collections go on. There are also opportunities for deployed instruments, and there are calls for these, which, again, partners are welcome to participate in those. Next slide, please. Oh, and then on this slide, what I didn't mention is Gateway already has several experiments that are planned to go, and many of them are actually international collaborations. So now I want to shift gears here on my last slide to the CLIPS landers. So I talked to you about the science on Artemis up to now. CLIPS is another very useful platform for doing science on the moon. One, in fact, additional factor with CLIPS is that they can take your payload to any part of the moon. Previously, when I was talking about the Artemis payloads and experiments, we're focusing on the South Pole. But with the CLIPS landers, you can actually go to other places in the moon. And then the second point I wanted to make on this slide is that, and CLIPS, of course, stands for Commercial Lunar Payload Services. It is explicitly for doing science on the moon. These are commercial service providers who have platforms that can take your science to space. In fact, I know several representatives of the CLIPS community are here. I had lunch with a few earlier today. And so anyone is able to approach and work with these providers to get your science on the surface of the moon. And with that, I'll stop and hand over.
Okay,
I'm Hiro Sasaki, Vice President of JAXA, in charge of human space flight and space exploration. It is my pleasure to be here and to attend these plenary sessions. And I will explain the JAXA role in Artemis program. For Artemis 1, we don't have a contribution on the system of SLS and Orion, but we prepared the 2 CubeSat on the SLS, and Omotenashi and Eclipse. Eclipse is flying smoothly for a long time and conduct the demonstration of the technologies and also collecting the science data. And JAXA also conducting the development of the 2 missions on lunar surface. One is SLIM, and the other one is LUPEX. SLIM means a smart lander for investigating moon. Was launched successfully last month, and now it's flying smoothly toward the moon. And landing will be held early next year. And the LUPEX is a joint mission with ISRO. ISRO was conducting the good landing successfully. And we prepare the rover, and ISRO prepare the landers. And it will collect the data for the water resources on the South Pole region on the moon. And next chart, please. And also, we are planning to participate in lots of activities on Artemis program. First one is Gateway. JAXA is developing and preparing, provide the Eclipse system to the iHub, and also developing the HTV-XG to resupply the cargo to the Gateway. And the next one is crewed pressurized rover. It will be, JAXA now is studying with Toyota Motors to contribute to the lunar surface activities. This will be, the crew will be about without a spacesuit, and it contributes to the sustainable lunar explorations. We also conducting the several missions preparations, such as navigation and communication, and also transportation on the moon. We hope we can contribute to the Artemis program from now.
Good afternoon. First of all, thank you for the invitation for this plenary session. My name is Miguel Bello Mora. I'm the director of the Spanish Space Agency. We start operation in April. We're only 5 months old. We're probably the youngest space agency in the world today. But in spite of that, space activity in Spain started a long, long time ago. In particular, lunar exploration started in the 60s with agreement between NASA and Spain to put a deep space network antenna in Fresnedillas, close to Madrid. And the very famous picture of the Earth, the very first one of the Earth taken from the moon, was received in Madrid, and also the Apollo 11 descent data was received in Madrid for the Apollo missions. And since then, we have been working in lunar mission. We were actively working on the Smart 1, which is a European mission, an ESA mission to the moon. And we are highly interested on science and instrument, but also in the technology in the lunar vehicles and spacecraft. We contribute to different parts of the Artemis program. In the Gateway, we contribute in the Spirit module, we contribute in the iHub, we contribute also to the European Service module. Next one, please. We have 2 avenues of collaboration in Artemis. There's one through ESA, through the European Space Agency, another one bilateral with NASA and with US companies. For instance, we are doing the power system, or the iHub for ESA, but we do also the power system for the Halo NASA through an agreement with US companies. We also are doing the docking systems, and we are doing also communication antenna for the different modules. Next. On the European service module, we are responsible for the thermal control, please. And for the next future, for our contribution to Artemis in the future, we look for areas where our industry is very capable. In particular, guidance, navigation, and control. Scientific instruments. We are providing scientific instruments for Mars exploration. All NASA rover have some Spanish instrument or meteorological station, different type of instruments. We also are specialists in power and thermal control systems, advanced robotic and autonomy. Also in situ resource utilization. We have some capabilities in this domain. And in particular, we are going to planning small orbital mission with small sats, rover, and as I said before, thermal control. Those are the lines of future activity of Spain within Artemis program. Thank you.
Thank you, all of you, Jim, Sharmila, Sasaki-san, and Miguel. So the first question, to Jim. With the completion of Artemis 1 and the development of hardware already underway for subsequent missions, how are the lessons learned in Artemis 1 impacting these future missions?
So Artemis 1, as I mentioned, was really to test the systems as much as we could before we put crew on there. And I'll say, I think the lessons learned activity wraps up this month, but we looked at lessons learned all across the board, from technical to all the way through how do we communicate with the public during the mission. And from a technical perspective, the things that we've learned, I'll point out one that we're still working through the final disposition on is the heat shield. We had a very unique re-entry that we've chosen to give ourselves a lot of cross-range capability to land where we want to land with the crew to avoid weather. And that has a skip entry where we enter the Earth's atmosphere and then actually skip out and skip back in to give us more of that cross-range. That puts a lot of demands on our heat shield, and how the heat shield behaved from a temperature perspective was very good. There's some other mechanical ways that it behaved that we're working through the final disposition of that. Obviously, that will inform every mission going forward, how we do the skip, how we do our re-entry. So I'd say that's probably the biggest lesson learned across the entire program. And I think the other thing that I'll point out that's different for 2, so I talked about we tested everything we could. We've added a lot of hardware for 2 for the crew, right? We didn't have displays. The Commander Munikin Campos that was in there didn't need any displays while he was on 1. And we, hand controllers so the crew can control the vehicle, a lot of life support systems. So they'll be learning on every mission that we do. 2, we'll take a stepwise approach through it, where we'll go into a 24-hour Earth orbit and test everything that we can before we commit to go to the moon. So we're actually doing testing within the test mission and taking things stepwise. And then for future missions, we'll start to add hardware. For Artemis 3, we'll have our lunar lander, we'll have spacesuits. Those are in development today. Gateway, that's been mentioned, I think, now by all of us, is in process today. The logistics outpost actually had its final weld done today in Italy, I was told earlier. And so all that hardware is in development, and we'll continue to add to each one of the Artemis missions. And as I said, Artemis 4 on, we'll base all our landings from Gateway, with our focus on science. Sharmila talked about the science that we're going to be doing. That is completely our focus. We're putting humans up there to do science. We'll also learn how we behave in partial gravity. That'll help us as we go on to Mars.
All right, so Artemis isn't the only lunar mission that's occurred recently. We've also seen the success of the ISRO Chandrayaan 3 lander. Sasaki-san, since JAXA is also planning a joint lunar landing mission with ISRO, any lessons or takeaways you've had with that excitement?
Yeah, first of all, the landing of the Chandrayaan 3 was a great accomplishment for humankind, as it is successfully landed near the South Pole region of the moon, which is the main setting for the Artemis program. And as I told, we are currently developing the rover with ISRO. And we are welcome to ISRO has increased the certainty of the development of the lunar lander. But first, I would like to follow India's successful landing in that stream.
This was very exciting. So the first one near the South Pole for us to lean on. So Sharmila, and speaking of science, with Chandriya-3 has been working on, the lunar scientists are also very busy right now, and the Artemis 3 geology team was just selected. We also have analogs for learning. So how do you see analogs fitting in as we get closer to crewed missions?
Yes, Najud. So analogs I see as being very important for science and for investigators to use as platforms before you launch your mission to deep space. And so analogs that we've been using traditionally come in two flavors. You have the physical analogs, so for example, sites on Earth that have dry, arid conditions and rocky conditions where the dust and the rocks composition can be similar to that in the moon. And then you can use analog stations like that for training crew, as well as testing equipment like rovers, et cetera. So that's one kind of analog. The other kind of analog that we also use that's very helpful as well are operational analogs. So this would be where you can recreate some of the elements of spaceflight, whether it's isolation, whether it's elevated radiation, et cetera, on Earth, where you can test your science or your hardware or the response of human subjects as potential crew members in space. And so, of course, world over, you have the NVHAB in Germany, you have the NEK in Russia, you have the Antarctic stations, we have the Human Exploration Research Analog at NASA's Johnson Space Center. You have the NASA Space Radiation Labs for elevated radiation. So these are analog environments that we've used for science to get ready for missions that have been very helpful. And a couple of other analogs that are also very innovative, I think, is now ISS is being used as an analog for doing experiments, long duration experiments for the moon in preparation for getting to the moon. And then, of course, the moon will serve as an important analog for science and research for Mars. So, Najud, I think analogs will continue to play a very important role for science.
Certainly. What about, for anyone perhaps, how do we bring the public more into these activities around analogs?
Yeah, I can start with that. I was just going to say that I think the public has been very engaged because there are all these international locations. Investigators are able to use these much more easily than the few missions that they get to go to space.
Yeah, well, for us, those Artemis, especially the signature of the agreement, made it high interest on the public, which makes open to them the possibility that we are highly engaged in Moon and Mars. But most important, on the politician. I mean, the signature that we did was done by Bill Nelson, by the NASA administrator, at the Moncloa Palace, which is the palace of the president, in presence of the president, Pedro Sanchez, with the minister. That means we also need a political impulse for lunar exploration, and that helped us to get the political impulse, help our agencies to make it easier so that we can get financing those activities.
So Miguel, speaking of the public and engagement, how are the Artemis Accords viewed in your agency, and do they increase support for participation?
Artemis Accords have generated interest in space exploration in Japan, especially, not only for space agency, but also the industries and also government. And since Japan signed the Artemis Accord in 2020, the country has been focusing on promoting the international space exploration, including Artemis program. Even the space exploration's budget really was increased after the Artemis Accord signed. And Japan was one of the first group of the signatory of the Artemis Accord. And the Japanese government has been very active regarding the participation to the Artemis program. So the government strongly support for the research and development technology necessary for the lunar exploration, with the goal of sending the Japanese astronaut to the moon by the end of 2020. So JAXA hopes to meet the government expectation with the best of our technology and to play a major role in Artemis missions.
Miguel, any other comments on the Artemis Accords?
Artemis Accord? Artemis Accord itself is we just supporting the Artemis Accord because our technically supporting the Artemis Accord, but Japanese government signed, so it is difficult to say.
So Artemis will now present us with an opportunity for human involvement that we haven't had in lunar exploration for decades. What are your thoughts on the unique value humans bring to these Artemis missions, and especially with respect to science? Sharmila.
So, and then, you should definitely contribute to this as well. But I'll tell you from a personal perspective, I'm a great supporter of the human factor in there for doing science. And I'll just give you a couple of examples where from a personal standpoint of doing research in science, we have really relied on having the human crew member there with their expert support. So for example, back in the space shuttle years, for example, we were doing this experiment, which was highly complicated. It had many, many steps. It was a multi-generational experiment with live biological samples. Samples had to be fixed, frozen, brought back down live. So, went on for a long time with many moving parts there. And the German astronaut, Thomas Reiter, was the person doing our science experiment in space, and he did an absolutely perfect job. In fact, the experiment was so complicated that on Earth, when the ground control was being done asynchronously after the flight mission had progressed, there was some hiccups with temperature control and stuff with the ground control, and the ground had to be redone. But Thomas Reiter did a perfect job in space, which really saved us a lot of time and effort, because getting a second flight is a lot harder than repeating ground control. Another example, on the SpaceX mission more recently, we had another experiment where we were using a centrifuge for half our samples. They were going to be the 1G control in space. And suddenly in the middle of the mission, the centrifuge stopped working. And everyone was scrambling, trying to figure out what to do. And the Italian astronaut, Samantha Cristoforetti, again, just human ingenuity, she wrapped some tape around the centrifuge, and she pulled it like starting up a lawnmower. And lo and behold, the centrifuge started, and we were able to complete the experiment. So I think, both for very complex experiments as well as for troubleshooting, certainly for science, in my experience, having the human element there, especially how expert our crew members are, it has been very important.
I think that's quite important what you said. But human flight had all the three components. One component is that help to link society and space. Automatic system is far from the people. They don't feel that they affect them. But the first time we have an astronaut in Spain, people feel linked to the space because Pedro Duque was born in a normal part of Madrid, went to a public school, public universities, and everybody felt that they could be Pedro Duque. They could be flying. That means this gap between society and space is very much held by flying. Second thing is vocation. We need vocation for space, and astronauts are a public relation tool to promote vocations, especially ladies, because we are in Spain only 20% of women talent in space. Then we need to foster that. And we have now 2 new astronauts. One is a lady, Sarah, and she's the model of many girls that has no reference, and is the reference for the girls to be space specialists or increase in that. And the third one is a very long term. The third one, it is a debt with future generation. Our resources on Earth will end sooner or later for the population. Then we need to colonize other environments. And this is something that we have to do sooner or later. The sooner the better. This is a cost of opportunity. Then, in addition to what you said, that it is important for the exploration, there are other three aspects which are more related with the society, which I believe is quite important for human flight.
So switching gears a little, Jim, so to you, in terms of what NASA's been doing, we've been encouraging a lot of commercial partnerships for exploration. How would you characterize private sector investments and the interests that we receive?
I think we've been driving a lot of things for in the services contracts that we've gone out with. We've intentionally built off of the services we get for space station today in cargo and crew delivery to our human lander. I think our human lander, both procurements that we've done, we have one award to SpaceX and one award to Blue Origin, were for a service of providing crew on the surface and bringing them back to whatever vehicle they're docking with. And I think that we've leveraged what others want to do for their own private purposes. We maybe have advanced those a little bit with, I'll call it seed money, to bring their efforts forward. And I think we've taken that into our other procurements. We're doing that with spacesuits. Spacesuits are provided to us as a service. They're installed in the lander, and our crew gets in the lander, goes down to the surface, and the suits are there for them. We took a different approach with that. We obviously had a great deal of know-how within NASA on spacesuit development, spacesuit maintenance. We actually made all of that available to private industry and allowed them to access it, to provide proposals that perhaps were based on that. We didn't require it. But now we have that as a service. Now we're exploring our lunar terrain vehicle. We had a proposal, request for proposal out for that we received a number of responses to provide the lunar terrain vehicle as a service on the surface. That's probably the biggest stretch because that's never been done before. But we're kind of seeding industry to hopefully maybe bring some of that back. Some of that's allowed us to defer cost to NASA by private investment on top of contract awards. So we're trying to, I'll say, build off of our experience, but maybe take a more forward-leaning approach than we've done before. I think it's successful. The greatest question we always get is, where do you stop? How do you decide? We do have a very formal acquisition strategy council and approach that within the agency that decides from building it in-house to buying from a contractor to working with an international partner to buying it as a service. And we look at how that benefits our overall goals. And in this case, we bounce those against our Moon to Mars objectives, our architecture led by Najud, and see what best fits to meet the demands of our missions to get our science done.
So to follow up on that, a question from the app. Can you share any insights on the progress we've made with HLS providers?
Sure. Well, I think, I just talked about them being as a service. So our interaction with the contractors are through insight as opposed to oversight. So we have insight teams that work both with SpaceX and now Blue Origin, which are experts from across the agency in a variety of disciplines, as well as systems engineers. The progress is going well. I think you all know where we are with SpaceX trying to get to their second launch. Hopefully that'll happen here soon once they clear all the hurdles that they need to get through with the regulatory agencies. But beyond that, we were down in Boca Chica a couple months ago inside the simulator for the HLS that SpaceX is building, where the crew, what it'll look like for the crew, the environmental control, life support systems, thermal control, cockpit displays. They're obviously working on all their engines that they need. A part of those go with the upcoming launch. I think there's some hurdles that they have to get through, not just regulatory, technical. They have a number of launches they have to do for us. Next big milestone is where they do the cryogenic transfer from ship to ship. After that is an uncrewed demo, and then eventually our crewed demo. They have to launch a lot to do our missions, so we're looking forward to seeing them get on that pace. Blue Origin's a little bit earlier because we just awarded that contract earlier this year. They're marching to their early design reviews. Our insight team that works with Blue Origin is digging into the design, trying to make sure that we understand the areas that are of greatest concern to us around their design or just the mission in general. And then the other thing I'll say is we also have government task agreements where each contractor has requested a certain set of skills from NASA to help them do the development. So those our folks effectively go work hands-on with the developer to give them direct help. So sometimes it's really bigger than the program feels bigger than it really is. But we're focused every day because we're so down and in. Sometimes we need to take a step back and say, we're really pushing the limits with the contracts. We're pushing the limits of technical capabilities. And frankly, that's what we should do, not just NASA. We do as an international community for exploration.
Thank you. And in terms of international cooperation and our goals for further collaboration, Sasaki-san, science is an underlying principle of our exploration. It's one of our three whys we've articulated at NASA. How do you see science enabling more additional cooperation and collaboration?
Yeah, so I believe the international cooperation is an ideal approach to achieve the major science goals. As we moved away from the Earth, so technical difficulties and the costs increase. But we feel that it is very important to utilize each other's strengths to accomplish the major challenges. And also to share the knowledge and the data obtained among the international community. And I also think that science itself is as a common goal for humankind. So science community is very international itself. So science also support or make government to conduct internationally, I think. And for example, JAXA plans to be first in the world to return samples from the Martian moon Phobos with MMX. And this is an attempt to create new knowledge by combining the JAXA sample return technologies and Europe rovers and NASA systems. So such kind of activities support the similar missions and also create the international movement, I think.
Sharmila, anything to add?
Yeah, I just wanted to add to what Sasaki-san said. I agree with you completely. Science is essentially a team sport. It is about collaboration and cooperation. And so in the ways that you said and the ways that we talked about earlier, in terms of, the lunar geology teams, the instruments that will be going up on Artemis and Gateway, and so on, there are so many opportunities for international partners and industry partners. And something that I wanted to make sure that I mentioned also today is open science. And this is something, that you're probably quite familiar in astronomy, planetary science, earth science, biological and physical sciences. There are these open science databases. And I think this, and actually recently, so I'm in the Biological and Physical Sciences division. We have an open science database called OSDR, for Open Science Data Repository. And under that, we have Gene Lab, which is some omics data, but we also have non-omics data in non-human fundamental research. And so recently we partnered with JAXA, for example, to cross-reference our databases, the databases that JAXA has for its science in this arena with the ones that we have, so that when investigators want to go in and find data, it's easier for them to find data from both nations, from the work that's been done. Similarly, we're working now with ESA to figure out ways in which we can get the data sets that are coming from ESA, from their spaceflight experiments, for the non-human data that is, federated with our data, so it makes it easier for the community. But I think that also for this community at the IAC, it's an easy and a very convenient way to get involved in science, even when you don't have your own experiment flying, in the near term. You can use these open science databases to access the science compared with your own ground-based research, and then plan for future missions for Artemis or low Earth orbit, commercial platforms in the future. So I just wanted to add that.
In this area, I would like to recall what Stephen Hawking used to say, is that human beings is a kind of bride of monkeys living in a small planet in an average star, but we can understand the universe. This is what makes us different. Then this is the science will help us to understand the universe, and this is not a country endeavor, it's an international endeavor.
And I think one of the most important parts of that was the data. And data demands robust comm systems. So we do have a question in the app, needing all that common bandwidth. What is the interest in the international provision of communication systems and potential interoperability strategy? Miguel, I know Spain is involved in the communication system. Perhaps you could speak a little bit about the future plans.
I can hear very well, but you are asking about the future systems on communication systems?
Yeah, for communication.
Yeah, you know that in Europe there is a new program called Moonlight, which is a European Space Agency optional program, where Spain is the second biggest contributor after Italy. And the purpose is to provide communication and navigation services to lunar missions. And this is a PPP. That means it is funded by the industry, because the idea is to commercially provide that. That means that it is a step forward, offering, as we have geostationary or Starlink system doing communication on the Earth, to start also giving services on the Moon to the different missions of NASA, JAXA, or the players.
And Jim, any thoughts on the interoperability and how we encourage the international collaboration there?
I think the international collaboration, as I said earlier, is essential. We encourage the interoperability by how do we maximize all of our science return? We have very specific needs for our crewed missions, but we're going to have needs for all the instruments that we leave behind, or operation of our lunar terrain vehicle to do science when we're not there, and that science is going to have to be international based. So by making the interoperability standards what we expect everyone to work to, everyone will benefit by getting the science back. Everyone will be able to use different assets, either in high data rate scenarios or high data return scenarios, or when there's a problem, we can then still depend on getting the data back by using multiple, I'll say, missions or constellations or services. And I think all that's based on what we're doing today on the International Space Station in terms of interoperability, things that we proved out there with docking as an example.
So to leverage that, perhaps Sharmila first, do you see opportunities for small satellites to contribute to your science goals in future Artemis missions?
Yes, absolutely. In fact, on one of the early slides that I showed, one of the experiments called BioSentinel was actually an experiment that we did on a free flyer. And yes, so those are automated experiments, and I think they will serve an extremely important role in going to regions, in deep space and experiencing some of, for example, elevated radiation. And doing science in those areas on free flyers. I think free flyers will serve as a very important platform for us as well.
Any other thoughts on small satellites? Perhaps Sasaki-san?
I'd like to want to say that interoperability, I think, is important for the international collaboration. So interoperability or same standard, using the same standards in case of the ISS program. So we can, NASA is, JAXA, combined as the same system. And also, in case of the communications, also we need to set up the interoperabilities, and so we can easily coordinate to the frequency or some systems. So such kind of activities are important for the international collaboration.
So a little bit different. This question is to NASA, but I think it's equally appropriate for everyone. What is NASA doing specifically to address the physiological and neurological challenges that our astronauts are facing with long-term space occupation? Sharmila?
Yeah, that's a great question. So definitely, the good news is we know we've been to the moon and back, so that's the good part. But we also know from all the work, all the studies that have been done on the International Space Station, that there are effects, neurological and other physiological, like immune, cardiovascular, effects on the muscle, effect on the bone. So there are several ways in which these are, and one of the things that I mentioned briefly is using the International Space Station as a long-duration analog for future lunar and Mars missions. That's been one very important way in which we're beginning to get a sense of what long-duration exposure to spaceflight in reduced gravity or microgravity, as well as elevated radiation. So that's one way. Other ways in which we are doing preliminary work that will help us towards deep space exploration is, of course, ground studies. And, for example, using facilities, Chiba, Japan has facilities, Europe has facilities, the US has facilities where you can simulate deep space radiation. It's not ideal in that you get the same composition of radiation particles, but it's not the same dose and dose rate and the continuous exposure that we will get when we're in those modes, which is why you have to also do the space flight studies. And that previous question about free flyers is therefore very important. So a combination of doing things on the ground, doing things on free flyers, doing things on the surface of the moon, and doing extended duration studies on ISS, all of these are what we're planning to help us get to that ultimate goal.
So a little bit going off that. So how do we ensure we have enough data in the physiological and biological realm to assure that we're ready for Mars?
Yeah, that's an excellent question. And I think one of the biggest challenges at this point is the effect of radiation, because that's something that we probably know the least about in some senses. On the other hand, the good part is that there are a lot of sensors we just talked about. There are sensors, again, that all these international agencies are partnering to get sensors. On Artemis 1, there was also a vest. This was, again, an international partnership, as well as with international industry, where they were testing a vest that could protect protect the soft tissue organs inside our bodies to see how effectively this particular vest could protect us from this deep space radiation. So I think really the answer to that question as to when will we be ready, when will we feel ready to be in Mars or go to Mars, I think will rely on continuing the science that we're doing on Artemis missions, continuing the science that we're doing in low Earth orbit, continuing the science that we're doing on the ground. And as we've seen, we weren't sure if we'd be ready for the International Space Station. And lo and behold, 20 years have gone by and we've got a lot of research done there. And I would predict that it would be similar in our aspiration of getting back to Mars, is all of the work that the science community does will build towards giving us that confidence to do it.
So a bit of a question for a few. At what point will Gateway be functional, and do you imagine it being somewhat like the ISS, aka an internationally cooperative science-focused destination? Perhaps, Jim, you can start.
So right now, Gateway will launch between Artemis 3 and Artemis 4, and we'll do our first landing on Artemis 4 staged from Gateway. And that'll be the be launched with the habitation and logistics outpost and the power and propulsion element. Those will be launched together on a Falcon Heavy vehicle. The Artemis 4 launch will take up the international habitation provided by ESA and the life support by JAXA. The Orion will push IHAB and dock it to Gateway. We're doing science as soon as Gateway's launched on the Falcon Heavy. So from my perspective, Gateway's going from the get-go for science. And then we'll slowly add to that. There'll be the Esprit refueling module, also provided by ESA, will be added to Gateway. And then we'll have logistics vehicles provided both by NASA and eventually by JAXA.
So with all that collaboration, maybe Sasaki-san, what science do you see in Gateway's future? What science do you see in Gateway's future?
ISS?
Science on the Gateway.
Gateway. So future now. So compare the environment of the with ISS. Gateway is very different from the low Earth orbit because radiations or something. So we want to collaborate the collecting the data for such kind of environment, and also since it is difficult to say, but the Gateway is very smaller than ISS, so we could not put the big instrument in a Gateway, so we need to collaborate and joint small instruments are necessary to conduct the science.
So in terms of the surface of the moon, we've had a couple questions about the plans to protect the far side of the moon from radio frequency interference. It's a precious place to build future telescopes. So how will we protect the far side of the moon?
It's difficult.
How do you protect the far side of the moon with radio frequency?
Radio frequency, yeah. So I'm sorry, I is not a specialist for these areas, but we are now learning to how to protect the data, radiations or something. We often talk with NASA and ESA to proceed development work.
So Jim, anything else to add on protecting?
I would say, going back to your question about the Artemis Accords, the first thing we're trying to do with the Accords is preserve the pristine environment on the moon, both at the South Pole, where it may be resource rich, or where significant observations can be made from the moon, like the far side, where you get away from that radio interference. Actually, one of the topics at the Accords meeting today was one of the working groups had looked at how do we make sure we don't have interference on the lunar surface, not just landing on top of someone else's lander, but also how do we keep the scientific viability of the moon. I think that'll be an ongoing set of analysis and studies that we have to do. I think we need to start, and I don't know that the science mission directorate has started this at NASA. I've heard it from some of our international partners, is start looking at what are those missions that we can do on that far side in the near term to gather some of that, so that if there is unintentional interference, that we can benefit from the science before those that could get potentially obstructed.
So just scrolling through here. So keying off that, a question: who will regulate what happens on the moon?
Who will regulate what happens on the moon?
I'm sorry that maybe Jim is a good person to answer.
I like that you had to answer first. That was a better way. I mentioned the Accords. The Accords are the principles by which we're going to operate. So I don't think there's going to be anyone that regulates what's done on the moon. I think the principles how we operate are going to do that. And that's trying to not disturb other folks' sites, trying to keep those science areas pristine, trying to respect the history that's on the moon of what's already landed there. We don't want to land on top of, we don't want anyone, we wouldn't, but land on top of the Apollo 11 site or disturb that site because we think that's important to human history. That's why for us, the accords are so important, and the 28 other countries that have signed it are so important because we feel like that is our way to mutually agree on what we're going to do on the lunar surface, because there isn't that body that can or should regulate it. It's how we operate, and we hope that more countries sign on to agree to those principles around which we're going to protect the moon and not, in some cases, do what we did to our own planet here on Earth.
Well, it's clear that United Nations, UNCOPUOS, is who has to play this organize what happened on the surface of the moon. But we have more urgent issues, which is what to do on the Earth. We need to go first to the space traffic management on the Earth, and then we organize what happened in the moon. Because we have some important duties to do in the very short term in space, but probably we'll need to hit today high priority to space traffic management on low Earth orbit, and then go to United Nations to organize what happened in the moon.
All right, time for a couple more questions. So first one, looking backwards, what are some of the biggest differences between Artemis and exploration today and Apollo?
I'll take kind of the vehicle side of things, and I'd love for you to address the science side of things. From a vehicle side of things, number one, we would not know what we know today about getting to the moon without what was done on Apollo. We never want to overlook what Apollo has given us from a technological perspective, from a lunar environment perspective. We never want to lose sight of that. So anything I'm about to say is just built off of Apollo. I think we've built a vehicle in the Orion capsule that's capable of 21 days in deep space. That includes some ability to protect for radiation. That includes the life support systems. So I think and obviously it carries 4 people. It's designed for those 4 people to leave and all 4 go down to the surface. I think we're trying to go back for a sustainable exploration, which to us means getting 4 people down to the surface and staying for 30 days to get that longer duration exposure. We're trying to get to a point where it is truly a broad international collaboration to go there. We went there for a specific reason in the 60s from a specific mandate from our president. Now we're going back, and as Sharmila talked about for Artemis 1, we're going back internationally on science and in the vehicle. So to me, it's built off of Apollo, but we're trying to take that next step with Mars on the horizon.
And I can take it to build on what Jim just said, agree with everything Jim just said. For the science as well, I think it's building. So to give you one example, we're very interested in the effects of regolith, on humans as well as biological systems, as well as a substrate to grow plants for long-term sustained stays on the lunar surface and in future in Mars. So far, we've had samples from the Apollo collection, which has been very useful. They've been very carefully archived at Johnson Space Center. But as a scientist, to get those samples, because they're so exceedingly precious, it is not easy to get samples to do science from the Apollo regolith. However, now that we have the hope and the expectation from Artemis 3, 4, 5, et cetera, that more samples will be collected. And then, of course, you probably all heard, we just got samples back from an asteroid recently. And so as more and more of these samples come back, it just allows all of us to do more science. And so we will now be able to access that regolith material. Regolith is sort of the dust that you get from the lunar surface or from the asteroid surface. And we'll be able to start doing more extensive tests to see, are there any subtle or not so subtle toxic effects? If so, how can we counter them? Can we grow plants on them? There's actually a study that came out last year, which was very exciting, that showed that we can grow plants using lunar soil from the Apollo missions. But it was tiny amounts of soil, only one very simple experiment. But we want to grow those experiments. We want to learn more. And having more and more science done and more samples collected and brought back from Artemis will help us grow what the Apollo era started.
So for our last question, looking forward, Sasaki-san, how can we use the moon for expansion and exploration beyond the moon? What are your goals?
Beyond, yeah. So at this moment, so JAXA is the target is only on the moon at this moment. But of course, the moon is a demonstration, technical demonstration area to go to the Mars. So just personally, yeah, our goal is to human presence in Mars.
And Miguel, how about your country?
Well, it's clear that it is a step toward Mars. That's natural, and we will check all the life support systems. We can check all the different things that we need to go to the next step, and that's have to be done in the moon with 2 days distance, and this is a good step to go to a 1 year distance, which is Mars.
Well, thank you all. It's been a great conversation, and thank you to the audience. Thank you, and appreciate all of you joining us here today.